So hi, it's me again. This is the afternoon nap time talk, but I will try to power through this. So hi, I'm Yoav Weiss. Wanted to talk about task attribution, and I've been around the web for a while. And back in 2016, I filed this issue where I said that we need to be able to keep track of which resources loaded other resources and be able to have that information in resource timing in order to be able to build dependency trees and optimize the loading of critical resources. The answer to that was that we currently don't have any way to know that a JavaScript task initiated another JavaScript task. Then in 2017, developers were telling us that long tasks, the long tasks API, without any attribution is not very useful because you have a problem, but you don't really know what to do with that. There were some plans for partial attribution that excluded many things like promises and microtasks. But those plans never really materialized. And the subject came up later again, and the answer was that it's hard because we don't really have a way to know if a JavaScript task is the initiator of another JavaScript task. And then in 2019 in WebPerf working group meetings, and then later on in 2020, the subject of monitoring soft navigations and SPAs came up. I talked about a bit about that yesterday. And in those discussions, we talked about a bunch of heuristics that could work for detecting those soft navigations, but those relied on knowing what actions a user click event actually triggered. And that wasn't going to fly because we don't have any way to know that a JavaScript task was the initiator of another JavaScript task. Now, you probably don't see it, but to my expert eyes, a pattern was starting to emerge. And what I found out over the years is that when people tell you that there is no way to do something in software engineering, that typically means that there is no current infrastructure to do that just yet. And infrastructure can be built, so we did. After a few wrong turns and a lot of iteration with the V8 and scheduling folks, and special thanks to Scott Hazley, who's here somewhere, we got to something that actually works. So task attribution in Chromium today, how does it work? For each new JavaScript task, we're creating a task scope. And new tasks that are created while a current task scope is active are that scope's descendants. And we keep track of the ancestor-descendant relationship in a container. And those tasks IDs are also passed on to V8. So when new promises are created inside of V8, they know their ancestor ID. And hence we can keep track of the ancestor of various promises and other tasks. The use cases for this. So I talked yesterday about soft navigation heuristics. This is the main motivation from my perspective to get this work off the ground. I won't expand on this more. For long task attribution, I think this is something super important to be able to debug long tasks and figure out why they're happening. This is becoming more relevant in the context of FID and INP and being able to, the full developer story around those responsiveness metrics need to address long tasks, and developers need to know where those long tasks are coming from. For resource timing initiator info, this is also something I think that can be very useful for various RUM providers to be able to tell people that for example, these are the resources that were in the critical path of your LCP resource, and then enable developers to focus their optimization efforts on those resources. Another cool thing that I think we can do is the subject of transitive prioritization. We have fetch priority attributes that enable developers to tell the browser that a certain resource is a high priority or low priority. Scott is working on execution priority, and we have for a post task, for example, we can say that a certain task is high priority or low priority. But those priorities are not currently transitive. If a resource is loading another, like a high priority resource is loading another resource, that the priority of that other resource is just the generic priority that's based on its destination and other rules that we have for prioritization. The developers cannot indicate that prioritization further down the chain. And same goes for tasks. If we are executing a high priority task that is then scheduling some other task, unless it's explicitly specifying that priority, it can be any arbitrary priority there. So I think this can be an interesting case. Similarly, for various privacy protections, I think we could have certain limits on what certain tasks can do. So, for example, if we have a third party that is known to be, I don't know, a fingerprinter or some other abuser of users, we could limit access for various APIs from all the descendant tasks of this particular third-party script. And similarly, we could do the same thing for performance reasons. So if we have a script that is known to be bad performance-wise, we could limit the prioritization of all its descendant tasks. Or there are various interesting things that we could do on that front using that infrastructure. Another thing that I think would be super useful is deprecation attribution. So right now we give developers deprecation warnings if they're touching on APIs that we are interested in removing from the platform. We give them deprecation reports, send it to their reporting URL, like the reporting endpoint that they define, but we don't tell them which script, for example, touched on that deprecated API. So if you're loading 30 third-party scripts, you don't really know as a developer which of them is doing the thing that you don't want them to do. So providing some attribution there could be useful to get more achieve better successful deprecations. And I believe that there could be other use cases for this. So essentially, I wanted to share this with y'all. And yeah, if you have a use case you can think where this could be useful, please don't be shy. The current limitations for the current task attribution infrastructure is pretty, it was made to address the use case of self-navigation heuristics. It can be expanded, but right now it has some limitations. So right now the tasks can only be queried from a JavaScript context. So only as while JavaScript is running. The internal data structure is used to answer questions about the ancestors of the current task, but not necessarily for its descendants. So this may change if we would want to answer to, for example, know when a self-navigation is done and all the descendant tasks are done, but this doesn't currently work. There could, but I have plans on how it can be improved if needed. And currently it is not watertight. So right now, malicious scripts can, for example, override functions that then would be called by other scripts, and the ancestor task in this case would be the other script rather than the malicious script. If we wanted to make sure that scripts can't escape, like if we were to apply privacy restrictions based on that, we need to make it tighter, make sure that scripts can't escape the box. In terms of a cross-browser story, right now this is a Chromium implementation feature. It is not specified, but my plan is to specify it and standardize, if possible, as a platform concept, not necessarily as a directly exposed web API, but as something we can build features on. And with the clear examples of I want to web expose soft navigation heuristics and long tasks, and for that I need something that hooks into the into the event loop, and and it would enable me to define those concepts without hand waving too much. So that's all I had in terms of slides, and I would love to hear your thoughts.
All right, we'll do an in-person first because they raised their hand before the one on chat did. 1 second.
How does this information not grow without bound over the life of a page? And also, if it is just a global tree of attributions, don't they all go back to the parser task eventually?
So right now it's just JavaScript tasks. So
the first JavaScript task will be something that's run during parsing or loading, right? Load event or a script tag.
So the script tag execution would be.
So at any time we want to say, what's the headwater for this stream of tasks, it's always going to go back to the script tag parse, right?
Not necessarily, because there is no so you have the tasks that run as part of the execution, but then you have tasks that are run as a function of user interaction and events that are running. So
I see. But I see. So you're not tracing through event registration at all.
Yeah. So
okay.
Yeah.
Okay, that makes more sense. What about what about like a RAF loop?
So
is that an event? Considered an event?
A RAF loop. So RAF is I'm considering. So for some tasks, we do consider the registrar as the parent, but not for most. RAF is one of those. RAF and web component related. Web component of lifetime events and performance observers as well. Also, so the registrar counts there, but not in other cases.
Okay, so then the attribution chain for a RAF loop would grow without bound.
What do you mean will grow? Oh, if you have a RAF loop that is calling RAFs, currently, yes. Currently, the container I'm using is bounded. So if you're doing a full loop, you will lose the ancestry. That's I agree that in theory you could have tasks that trigger tasks that trigger tasks.
I don't think it's a theory.
Infinity.
I think that's normal. I think that's common.
In those cases, I am fine with not being able to know what the original task was and lose that chain at some point.
So I'll just make a quick suggestion, which is a lot of the times when you're tracing ancestry, what you're looking for is some sort of like a tag or a label or a restriction or a policy that's being pushed down, like prioritization or some other, I don't know. And so if you could figure a way to push those labels down as tasks respond so that you don't actually have to crawl the tree every time, but at the moment that you create the new task, you simply apply labels that stick to it forever, then you don't need to ever trace attribution. You already have the labels applied. Does that make sense? So all you ever need is like the leaf of the transitive closure. You never need to know ancestry if you can identify significant properties that you would like to be able to keep track of. And I'll hand off the mic.
Interesting.
Robert, you said that was exactly what you were going to ask. Do you still have something?
Yeah, that is almost exactly everything that I wanted to ask. I wanted to add a slight clarification that, like, if we are using this as a security or priority boundary, we probably do need to care about event registrations as well, because you could add a registration to some content that exists in a higher priority context maybe, and that might not be something you want to allow. But basically my main concern was the same thing. Like, at some point we need to clean up the ancestor chain.
Yeah, I agree. Right now it's bound and just it's being continuously overridden. So
We've another in person.
So I think earlier in the talk you mentioned the long tasks API and trying to attribute the origin of those long tasks. Are there other ways this information is or could be exposed to web developers, maybe through DevTools or something, to give them like ways to kind of go through the task ancestor chain and look for opportunities to optimize?
So the problem with DevTools is that they are open on the developer's machine while the developer is developing things, and not, they don't give you that information from the wild. There's a straight, so there are ways for developers to know about long tasks that happen in the lab or during development time, but that is not sufficient. And if you're running into responsiveness issues in the wild because, of network conditions or the user's device or anything else that or like a certain user scenario that you didn't consider, you want to be able to collect that data from the field and be able to attribute those long tasks, those responsiveness issues to, to whatever happened in the field. So,
but I think you can like capture heap profiles and some other data from the field and then load it into DevTools. So maybe like some way to capture that state.
you can, yeah, that is not currently sufficient. It could be potentially a workaround. There are also like there's the JavaScript profiling API that enables you to get deeper insights, but it's not. It has significantly more cost than just long task reporting, and it's not tied directly. You would have to correlate times. It is theoretically feasible, but not necessarily practical.
One more in person, then we'll hit Robert, and then we'll be done.
So Node.js has an async local storage API that lets you do something like have if you have an async local storage object, it seems like you can set some set it to contain something, and that you can get it in like tasks that depend on the tasks that set it, and so you can have different task trees, and you can get the stuff that got set on the last time that it was set in this tree, right in this branch of the tree. And it seems like something like that is being proposed also for TC39. I was curious how whether this relates to that in some sense. Or...
I'm not aware of this effort, but it sounds like maybe I should be. So yeah, let's catch up and.
Okay.
I was thinking in relation to the previous comment that we could tie this to performance reporting APIs. So like if you request to listen for long task attribution, then we would start recording all of this ancestry information, and that would be a trigger similar to the developer saying they want to record something in DevTools, but allowing it in the wild.
Sure, but like right now, this is being recorded by default without any, like, there are no performance regressions. So like one of the strict requirements here was that this can be like on all the time without any, like without overhead. There was some overhead in one of the like JavaScript benchmarks. We kind of trimmed the proposal, like basically this being on all the time and low overhead seemed like an important part of making this work.
Cool.
Cool. And with that, thank you.